So this presentation is going to be, I'll be talking about FHIR Compatibility Demystified. It's going to be a two-part presentation. So the first part is going to be more talking, and the second part where I hope to showcase an actual demo of this idea of FHIR compatibility, how it works. Okay. There's a lot of confusion, a lot of misconception about what this whole concept is about. So I try to explain this whole idea of FHIR compatibility in this two-part series. So intro. The agenda would be introduction to FHIR, just a basic, brief, high-level intro to what FHIR is, what it stands for, what has been its journey, its evolution, all of that. And then different FHIR paradigms, different uses of FHIR, if you will. And then what it means to be FHIR compatible. So what it means to be for your software or your healthcare applications or EHR systems to be FHIR compatible. And finally, in part B, I'll be showcasing a demo of the end-to-end demo of making a very traditional or any EHR or EMR system, how we can make it FHIR compatible. So introduction. So about myself, I'm Atul. I'm a software engineer by training and profession for the past 20 years. I'm heading a consulting business based in Bangalore, now in the US as well. So we deal with healthcare HIS systems and a lot of open source applications for enterprise as well as healthcare organizations. Okay, so a quick intro about FHIR. FHIR stands for Fast Health Interoperable Resources. So it is maintained and managed, or the organization behind the evolution of this specification is called HL7. HL7 is a US-based organization. So it has been there for a long time, and it has been behind a lot of evolution of a lot of healthcare data standards, interoperability standards. The previous versions were version 2, version 3, which were mostly XML-based standards. And 2011 was when FHIR got started. The specifications around this. It's a modern specification based on JSON and XML. JSON is widely used across the ecosystem. So basically, it's an interoperable health data interoperable standard. So to be able to healthcare systems to communicate between each other in a standardized way. So it has a wide surface cover of almost all imaginable healthcare resources which are currently operationally in use in the current healthcare domain, healthcare systems domain. So it has resources like patients and patient encounter, clinical observations, clinical diagnostic reports, and insurance-related eligibility criteria. A lot of these vitals, observations. So all of these are covered. The resources are covered in FHIR landscape. And apart from the fact that it provides the resource representations or the data model representation, it also has specifications for communicating between systems or REST API implementations, and also it has specifications for vendors who can develop servers to store these clinical data repositories. Also, a new paradigm of called SMART, which is an application development standards and guidelines specifications, which includes a bunch of things like authorization, authentication, how to store the data, API specifications, and also implementation guidelines. So it comes with a whole ecosystem of, and also a slew of tools which have been envisioned and developed. And here the reason why it is fast health um, interoperable resources. The fast is not because it's JSON or it's fast. Yes, it is fast. It's JSON. It's not really XML or any other or more cumbersome data models. It's JSON. But it's focused towards developers. Developers are the audience this specification is designed and meant for. So it's not traditionally healthcare resources were conceived or standards were conceived in the clinical domain. Clinicians, practitioners used to specify these things. But here, the idea is to make it more developer friendly so that developers can model and achieve healthcare use cases very fast. So it is really caught on, and it's going to be a game changer. As on today, many interest, a lot of interest, and the ecosystem is growing thanks to HL7 and the initiatives it has been taking. And on the right hand side, you'll see a diagram where how the architecture looks like if you want to make a traditional clinical data repository FHIR compatible. So I'll be touching upon this architecture and how the different ways in which your healthcare systems can be made FHIR compatible. So why FHIR is more important now than ever. So as on 2023, the ONC in the United States has mandated all major EHRs or any EHRs to exist in the country to be FHIR compatible. That means it has to work. It is to be able to send and receive data out of it, in and out of it, in FHIR format. So the work is almost done, and now almost all major EHRs, Epic, Cerner, Athena, all of them has built their own ways of achieving FHIR compatibility for all their HIS systems or EHR systems. So that kind of so COVID definitely was a real reason for fast tracking this FHIR development of these standards and the adoption of these standards of digital health. So COVID really fast tracked the adoption across the globe, and there are various implementation guides focused towards making the health data interoperable across countries, across regions. So the US core implementation guide is focused on the US region, whereas India has its own profile of FHIR or the standards specifications that the country follows. But there are certain implementation guidelines that we can make healthcare data interoperable, just like how financial data is interoperable. Like you can transact with your credit card anywhere in the globe, and which reflects on your host account or host bank. So this way of making healthcare data interoperable is the objective, and then COVID definitely really fast tracked the whole adoption across across the healthcare sector. Now, so it's very important now. As on 2023, almost literally all EHRs are compatible. Now it has opened up a whole paradigm of app development innovation and ability to facilitate more patient-centric applications and use cases that are being realized. Now the paradigms of FHIR applicability. So paradigms of FHIR applicability. So one standard, the traditional way which has existed, which was originally the intended reason for the the specifications to evolve was as an exchange, as a means of data interoperability. So here, India's ABDM, the HIE, all of these use cases just use FHIR as a means of document exchange. So you have from your clinical data platform, you just make a document representation in a JSON format or an XML format, and you just transact it to another healthcare system. So from one system to another system, you're sending data. So maybe it could be a health record, it could be a diagnostic report, it could be a patient patient demographic registration information. So these resources are just sent, and some data points are received as well. So it's just a mechanism to exchange data, and then you don't really worry about what you get back. The other use cases are messaging use cases. So it is mainly where you send data into a broker, kind of a message broker kind of an interface, and then you expect something in return. Some of the main use cases of implementation of NAFIS, which is the national insurance platform of the Saudi Arabia region, and NHCX, India's insurance HCX platform for insurance. Checking the eligibility for insurance, the processing the claim, reconciling the payment. So all of these use cases require a lot of kind of a messaging use case. You send something and then you expect something to come back. And the other paradigm of FHIR, which is one of the most rapidly gaining traction or popularity, or which has a wider impact, is the REST with SMART. So SMART is again an application. It's a REST-based app development paradigm of a use case of FHIR. So it is primarily realized for the US core implementation guidelines. So I'm talking very, very high level terms here. So the objective here is not to cover a lot on the FHIR itself, but just to give enough information that we can understand more about how to make your healthcare system FHIR compatible. So here, the US core IG is basically very so REST so uses it's an ecosystem of smart on FHIR apps. So if you there are a lot of app stores which has apps built on smart on FHIR. One of Epic has its own app store. Most of EHRs have their own smart on FHIR apps, and these apps are interoperable and it can be easily deployed on your FHIR repository. So here data is persisted in a FHIR server, and you can work with the data, clinical data, using REST APIs, and you can build apps, and it provides authorization, authentication, specification for authentication, authorization, and the different frameworks or different tools or patterns needed to build applications. So that's the idea of REST with SMART. So it's a very beautiful application framework where you can develop a lot of apps outside of your EHR, right? Imagine your EHR vendor has a limitation. They are a vendor. They are limited by their resources, whatever they can do. But exposing your clinical data, EHR, with a global ecosystem of smart on FHIR, open source ecosystem of smart on FHIR application developers who can actually develop very innovative apps, user-centric, patient-centric apps. For example, any specialization, you need a specific app. You don't have to go to your EHR vendor to do that app for you. You can hire a smart on FHIR app developer, and easily realize, hook it up with your EHR, and there you have it. So it has different launch flows, apps for patients, apps for providers, and all of that. So I'm just going very fast. Excuse me here. You can go to Siddharth Ramesh, the founder of MedBlocks. He has a YouTube channel which has good coverage on all of these topics. Some of the info I've taken it obviously with our collaboration with him as well. So here the FHIR compatibility for what? Okay, so all of a lot of people nowadays, we consult. I mean, I'm a digital health consultant. So when customers ask me, is your software FHIR compatible? They don't even know what that FHIR compatibility term means. So in a lot of cases, people don't even know what FHIR compatibility is. So FHIR compatibility means it could be in the context of your EHR, EMR, HIS system, your healthcare application system, patient care systems. It could be for your digital health platforms, right? And there are various platforms like Apple Health, Google Health, all of those different platforms. Those in that parlance, it could mean FHIR compatibility. It makes sense to be FHIR compatible. And then medical devices, wearables, the interfaces that it supports, whether it can input, output data in which FHIR understands. So these are some of the systems which need FHIR compatibility or which can technically be made compatible. The next slides onwards, I'll be talking about how to make a traditional EHR system like a traditional HIS system, like a Cerner Epic, or any for that matter, any dumb old HIS system or EMR system, FHIR compatible. So here there are different approaches. First approach is it could be called as building a FHIR facade, right? So here is your EHR database or your EHR itself, which has all the clinical records, which has been existing in your hospital for years. The data of patient data exists here. And now you, as a EHR vendor, can build a FHIR facade. So this is what the big players like Epic, Cerner, and all have done on top of their EHR. They have built a FHIR facade, and that enables application developers and use cases of FHIR, the paradigms I described earlier, to be realized on top of the FHIR facade. So this exposes APIs. You can work with REST APIs. So this facade is very expensive route. So you have your EHR DB and the EHR application talking to the EHR as it used to do, and then you're opening up the entire FHIR ecosystem through the FHIR facade. So here it's tricky because it requires a lot of effort is required, a lot of engineering development is required, write transformation code for all FHIR operations. So all the FHIR REST APIs for the respective implementation guideline you're developing has to be achieved here. So there are APIs, open source API. HAPI is an open source API of FHIRly. It's a commercial vendor for FHIR server. So you can use their APIs to implement this. It's a lot of work. And then you have to take care of your DB high availability as more requests, more use cases are realized on top of this facade. So this is what the big players have achieved. Good luck for what they've done. So this is expensive route. Now, the other more cost-effective, or I would say, somebody who doesn't have that kind of budget to, make your EHR software FHIR compatible, they can probably utilize something called this approach of full FHIR server implementation. So essentially, what here they do is the traditional EHR DB and its application exists as it is, and then you have a FHIR server, dedicated FHIR server. There are a bunch of FHIR servers. The vendors have developed FHIR servers. HAPI FHIR is an open source version. There are FHIRly, bunch of and even all the cloud players have their own FHIR servers, AWS, Google, Azure. So all of them have their own FHIR infrastructure. So you can leverage any one of those. Yeah. you can leverage any of those FHIR servers, and uh, then basically you can realize you can leverage any of those FHIR servers, and you can um, achieve this kind of a FHIR compatibility. So here, the challenge is you have to implement change data capture. So any CRUD changes on this DB has to be persisted on the FHIR server. So on your EHR, any patient or any resource, whatever relevant resource you're tracking against, or what your implementation guideline requires, you have to essentially persist it and ensure that it is in sync in the FHIR server. So there are ways, some modern tools and frameworks available to do that for this change data capture under the hood. And then, so from here, you have to transform the entities into FHIR resources and persist here. And here, typically, we don't encourage. So even if some data is getting persisted here, it has to be also reverse persisted back to the FHIR, to the EHR DB. So both read and write transformations has to be achieved. So the traffic directly comes to FHIR server, so we have to maintain high availability on the FHIR server, which actually takes care if you are hosting it on any of the public cloud providers' FHIR server. The availability part can be dealt with. Now, the last way of achieving FHIR compatibility for your EHR or EMR is writing. It's a hybrid model where you have the best of both worlds, I would say. So here we write via FHIR Facade. So all the write operations we channelize through a FHIR Facade. So we are not building a full-fledged facade for entire FHIR APIs, REST APIs. That is out of scope here. We are only handling all the write operations, and then you still have the change data capture and syncing with the EHRDB and the FHIR server. And you proxy read and write to appropriate channels. So all the writes will be proxied to the facade and all the reads to the FHIR server. So this is a very good way of achieving FHIR compatibility. So that is what essentially it means to be FHIR compatible. So you have three ways how you can achieve your FHIR compatibility for your EHR systems. Firstly, the facade way, which is the expensive route. Second way is implementing a full FHIR server with change data capture. And finally, taking the route of an hybrid approach where you have both facade and FHIR proxied by the read and write sub-proxied. So this is, to me, is the best way. So the next part of this presentation, I will be showcasing how we at Tacten achieved FHIR compatibility, integrating with another vendor-neutral platform, another digital health platform. So I'll be covering more on that in the next part of this FHIR compatibility session, which through a demo. I hope you found this session useful. Do reach out to me if you have any questions. So this is our website, www.tacten.co digital health, to find what the kind of service we offer. All right. So hope this was useful. See you soon for the next session. Thank you.